an example of using the quadratic formula on an equation. In this case, 5x squared equal 8x plus 3. I notice again that I can't use the square root method there because the x is not under the square or entirely contained under the square. So I'll go ahead and put it into quadratic form on the left, equal to 0. Remember again, the quadratic form is the ax squared plus bx plus c. First thing I might want to try, though, is to factor it. Does this equation factor? If you think about it there, the answer is no. I won't be able to factor that. So factoring, the procedure of factoring won't work. But I can use the quadratic formula. The quadratic formula said x is equal to minus b plus or minus the square root of b squared minus 4 times a times c, that whole thing, over 2 times the a. Now, in my case, the a is 5, the b is negative 8, and the c is negative 3. So plugging that into the formula, I would have x equal to minus b. Now notice that b is minus 8, so minus b would be a minus 8, or that'll turn into a positive 8. And then I have a minus 8 squared, b squared, minus 4 times a times c, and that whole thing divided by 2 times a. Okay, we got everything plugged into the formula. Now it's just a matter of simplification. Okay, so I have 8 plus or minus the square root of minus 8 squared is 64. Notice that I have a minus 4 times 5 times minus 3. That would be a positive 60, and then all divided by 10. So I have 8 plus or minus the square root of 124 divided by 10. I could simplify this further. I would have 8 plus or minus, and I notice that 4 goes into 124 31 times, and then divided by 10. So I'd have 8 plus or minus the square root of 4 is 2, and then factoring out a 2, I would have 4 plus or minus the square root of 31 over 10, and then I can take the 2 into 10 and end up with 4 plus or minus the square root of 31 over 5. I could also approximate this in my calculator. 4 plus the square root of 31 over 5, which is approximately 1.91, or the other solution, 4 minus the square root of 31 over 5, which is approximately negative 0.31. So this would give me both exact solutions, and this would give me decimal approximations of those solutions.